Hello, good morning. Things should be set up now. Okay. Does everything seem okay? Do you hear me? Do you hear me and see the desktop?
Yeah. Good morning.
Is it? Oh, wait a minute. My speaker's off. Okay. I turn on my speaker. Can you hear me?
Yeah, we can hear you.
Okay,
Everything's
great.
good.
Everything. Okay. Yeah, I had my speaker off there for a minute. Okay. Now, let's see. Okay, today we're going to finish talking about arrays. We're going to do an example, kind of a complicated example to show you some combination of how arrays and methods work together. So it's kind of a complicated example, but it's got a lot of ideas that are really important in it. So there's a reading assignment for next week. We're going to start talking about object-oriented program. We're going to start talking about the object-oriented programming aspects of Java, which is really important. Java is famous for being an object-oriented programming language. And we've kind of done that with strings and turtles, but we're going to see how to not just use objects, but to write objects. And that's we've been using Java as an object-oriented programming language, but we've been using objects, mostly things like scanners, strings, random objects, uh, the random number generator. So we've used objects called methods on objects, but we haven't written our own objects. So a big thing to learn is how to use Java to write objects. Okay. Okay. So that'll be the rest of that's the last topic we'll do. That'll take us up for most of the rest of the semester. Okay. And then with arrays, I gave you a couple problems to do in coding bat. Okay. There's like 3 or 4 array problems to do in coding bat. They're real nice problems, make you really think about using arrays. Okay. So there's a lot more. I kind of just suggested these 4. And probably next week I'll maybe give you a few more. But if you go to this here and you click on this, you see that there's actually a lot of array problems. There's a whole lot of them. They're really good for the most part. Very good problems. Very useful. Good. You have to program to learn programming. So this is a great way to practice programming. Coding bats is really well done. Okay. All right. So and if you have questions about these problems, ask. And if especially if you ask, if you want to try one in class, we can always try one in class next week. So look at these. If you have a question, you can always send me email. If you want to ask a question in class about one of them, we can look at them next week. All right. So try to do those problems. Okay. Now, here's what we want to look at today. Okay. This file, actually, I have it on my computer already. Okay, this is okay. So this is the file. You can download it. We'll copy parts of it. It's kind of long, so we're not going to copy the whole thing into Coding Bat. Or into the Java Visualizer. We're going to just copy some of it. So we're going to work with this a little bit at a time. Okay. So this file. We think of it as a library of methods. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 methods in it, and you can go down the list. There's the first one. There's the second one. Now, what this thing doesn't have is a main method. Like, you can't run this program. Okay, now, see, I've got it downloaded on my computer. So it's this file here. I'm going to open it in Dr. Java, for example. And you'll see that I can compile it, but I can't run it because it's not a program. It's a library. We think of it as a library. It collects a bunch of methods together for people to use, and people can write other programs that use these methods. So if you go through here, there is no main method anywhere in it. Okay. So if I click on compile, it compiles. Compilation complete. It created the class file, so it compiled. Okay. But if I click on run, I get an error message. Okay. Now let me show you what I mean by other people can use this. So let me create a new file. I'm going to call it use array method. Okay. So this will be a new class, public class use array method. And I'll give this one a main, public static void main string args. Okay, I won't put anything in there yet. Okay, make sure this thing compiles. So let me save it on my desktop, use array methods. Okay, so it compiled, doesn't do anything yet. Okay, wait a minute. Yeah, doesn't do anything yet. I can run it. Let's see, no. Okay, I can run it and it doesn't do anything. Okay, okay, now let me create an array. I'm going to create an integer array. And I'm going to, I can do two, I can create an empty array by saying int 10. Okay, but I want to actually create an array with some numbers in it. So as the book pointed out, the way to create an array with numbers in it is like this. So I can create an array with a bunch of numbers in it. Okay, so there's an array with a bunch of numbers in it. Okay, and if I want, I can, well, actually, yeah. I can print the array, but let me see what happens if I print the array. What happens if you just print an array? So compile this, run it. Didn't print very nicely. Notice that if you print an array, it doesn't print out very well. Okay, yeah, that's kind of a funny thing that when you print an array, it doesn't. They don't print like regular variables. So there's actually there later on we'll see some ways to print arrays, but unfortunately, if you just print an array, you get just this kind of weird, not very useful thingy down here. This is actually what the array prints. Okay. Now, what I want to do is in my library, I have a method called max and min to find the max and min of an array. Can I use them? So down here, here's what I could do. I can say int n equals, I want to call this max function. It's in this class, so I need the name of the class that holds the method. I say the name of the class dot max, and then I can give it my array. Okay, so that's how I could use a method in this library. You use the name of the library, then the name of the method. Okay, so compile this, see, and and then let me print out the answer. So system.out.println. Now see, in the Java visualizer, you don't have to print everything because the visualizer shows you the variables. But in Java, it doesn't show us the variables unless we open the debugger, but the debugger in Dr. Java is nowhere near as nice to use as the Java visualizer. So I could open the debugger to see the value of the variable n, but it's easier just to print it. Okay, so in Dr. Java, you get used to printing variables. But in the visualizer, the beauty of the visualizer is it shows you the variables right away. You don't have to do anything special to see them. Okay, so I can recompile this. Okay, now run it. Okay, the maximum number in here was 9. Okay, see, the 9 appeared a few times. And I could also then do, let me copy that and do the minimum. Okay, I'll call the minimum P. Okay, find the minimum. Notice I'm using, now when I call max here, it's not on the screen. It's not even in this file. It's over here in this file. Okay, and this file can't run. This file just is a library of methods. And this is the way actually the vast majority of Java programming is done. You don't write big program files. Very few people are going to write a file that's thousands of lines of code. What you write are thousands of programs that are 100 lines of code. And the vast majority of Java programming is a program usually ends up being hundreds of files, each file maybe being a few hundred lines long, and there'll be one file with a main method in it. The program will be 100 files, and one of those files has the main method in it. Okay, and that's the one where everything starts. Okay, so this is like so these two together form a program. This one by itself isn't very useful, and this one by itself can't be run, so you put them together. And that is actually the style of programming for all modern software. Each file should contain just enough information that makes it usable. It makes it a lot easier to find things. If you give a file a nice name, and then you give somebody 50 files with good names, they can find out a lot about how your program is written by looking at the files and their names. So they can see how things they can start getting a sense of how things fit together. If you give somebody a file that's 1,000 lines long that has all the code in one file, you can do that usually in Java, but then it becomes much harder to read. So breaking things up into files makes things easier to read. Okay, so now this one now I'm calling both the max and the min. Okay, and I can see I got 9 and 1, and if I want, I can put a negative number in here somewhere. Okay, that's the new min, and I can put a big number in here somewhere. There's the max now. So there's the max and the min, and I can compile and run it again. Okay, so the max is 123 and the minimum is -5. So I'm using the code from over here in here. Okay, so that's one thing. That this thing is what we will call a library. Okay, and notice I wrote it with the names of all the methods at the top. That makes it kind of easy to see what's going on. I purposely formatted this in a way to make it kind of easier to read. These are the return types. This column is the return type. This column is the name of the method. And this column is the type of the input. And this column is the input variable. So in this function takes in input array, which is an array of integers. And this function takes in input array, which is an array of integers. This function takes in an input array, which is an array of doubles. Okay, so you can kind of read it real carefully. Notice that some functions take in more than one parameter. So this function takes in input array, which is an array of integers, and a target, which is something to search for. So you search this array for that number. So it takes in 2 parameters. Okay. All right. Now, what we're seeing here are various ways of taking arrays as inputs and returning arrays as outputs. And the tricky thing is that some of these, the really tricky thing is returning an array as an output. Okay, when you return an array as an output, you have to be very careful. And that's what we want to show, is that there's more than one way to return an array as an output. Okay, we're going to actually see 3 different ways. So what we're going to do is we're going to take this inc array method, which is written 1, 2, 3, 4 ways. And we're going to see that there's 4 ways to give you an answer that's an array. Okay, and this is actually kind of, the books don't usually talk about this because they think maybe they think it's just too confusing, or they just have, the people didn't think to explain it. But when you start writing code and you start reading code, you're going to see everywhere people doing one of these 4 things. Okay, so when you want to give somebody an answer that is an array, you've really got 4 ways to do it. I'm going to show you the 4 ways, and this will be good practice in us thinking about how arrays work. So we want to work on just these 4 here. Okay, now what I'm going to do is to make it easier to work, I want to strip this function. I'm going to take everything else out of this library. So for now, let me take the other things out of the library. Make it easier to read what we want. We want to emphasize just those 4. Okay, so then I'm going to take the other ones out and leave those 4 in. So there's one of them, there's the next one, there's the 3rd one, there's the 4th one, and then for now, I'll just get rid of these. Okay, right? Now, let's go through and read what it says about these 3. Now, this one, now the names tell you a little bit about what's going on. you want to increment the numbers that are in an array. So increment the numbers in an array, increment the numbers in an array, increment the numbers in an array. Okay, increment the numbers in an array. Okay, now this one's going to do it in place. It doesn't return anything. What it does is it takes this array and modifies it. So when this function returns, what's in that array has been changed. Okay. On the other hand, this one is going to take that input array and not make any changes to it. Instead, it's going to create a copy of it, make changes in the copy, and then return the copy. Okay. This one's going to do the same thing, but we'll see. There's a subtle difference between this one and this one. We'll have to look at the code to see how there's a subtle difference between them. Okay. And then this one is going to take in an array. This is the array to increment, but then it's going to give us, this method will expect two arrays as input, except one of them is called output array, but they're really both input arrays. It's just that the data will be in here, and then as you increment these numbers, you put the incremented numbers in there. So you'll end up overwriting whatever data might be in that array. The real data will be in this array, and then each of those numbers will be incremented, and the result will show up in that array. So this array will be both input and output, except we won't look at its values when it's inputted, and the output, when the method returns, the real values, see, it's a little bit like this one here. See, this one modified this array. So when, after the method was called, this array held the output. It held the input before the method was called, and it held the output after the method was called. This one separates those two aspects. So you give it two arrays. The input data is in that one, just like here. But then instead of modifying that one, we modify this one. Okay, so let's look at the code. This will become a little bit easier to understand when we look at the actual code that does it. Okay, all right, so this one takes in an input array, and it just steps through the array and actually, it steps through the array, incrementing each number in the array. Okay, so it just, we'll call these methods in a little while. We'll write a method over here to call them. Okay. Now there's no, again, this is a library. There's no main method here, so we can go through here and think about what these do, and then we'll call them later. But what it does is it's making changes right in place in the array. It says increment that number in the array. Okay, and you start at the beginning of the array, work your way all the way to the end of the array. Okay. Now look at this one. This one has to produce an output array. Okay. So the first thing it does is it creates a new array called output array that has, it's a new array, and its length is the same as the input array. Okay. So it's not a copy, it's a new array that's got the same length as this one, and it's going to be filled with zeros. So we create a place for the incremented numbers. We create an array, same length as the input array, and it's got enough room in it for the incremented numbers in here. Okay. Then we step through the input array, and instead of incrementing the number in the array, we take the number in the array. See, this incremented the number directly in place. This is going to take the number, this is going to take the number in the array, add one to it, and put that, but see, that doesn't add one to in place. That gets what's in this array, adds one to it, then puts the answer in the output array. What does this do? This goes to the array, gets that number, adds one to it, and puts it back in that array. The way you should think about what this number does is it reads and writes to the same place. So it goes to that array, gets the ith number out of the array, adds one to it, and puts the result right back in the array. That's how you should think of that. Read and write into the same place in the array. Read what's there, add one to it, write it right back. Here, we read the number in the array. That's all. Then we pulled it out of the array. Now we add one to it. And then the result gets put back in the other array. Okay? So you haven't done any changes to this array here. Oh, if you changed this that line of code there, that line of code there actually is exactly what that line of code does. Okay, so if I wrote it like this, line 41 and line 24 are exactly the same thing. In fact, line 24 is just a short way to write line 41. You know, literally, this is just a convenient shorthand for writing 41. Read what's in the array, add 1 to that number, and put it right back in the array. That's not what we want to do, but if we want to put the result in the output array. So I'll put it back where it was. We want to put the in the output array. But a little change in this line makes it actually act like that line. Okay. Okay. And then there's a little comment here. What if I did this? Okay. Can anybody see? Suppose I did that instead of this line here. Suppose I had this line here. Can we see what that would do? This is a practice in reading code. It's important to start. If somebody says, I wrote that, that's what I want, but now you tell me what it does. What does this do that's different than this one here? Does anybody see? Can anybody think they could try to explain it? Give it a try. Try to explain. Read it carefully. Start on the right-hand side and ask, what does the right-hand side do?
The right-hand side, the input array I, that is that's basically pulling, like, getting a number from the array at the, or are you talking about the bottom one, the plus input array?
Mm-hmm.
Oh, that wouldn't that just add 1 to I before it before it gets the integer from the array?
No, it doesn't add 1 to I. It adds 1 to what?
To the final number?
What final number?
The number it pulls from the array.
Yeah, it adds 1 to the ith number in the array. Okay, see, it goes to the ith location in the array and adds 1 to that number, which is what it did here too. See, it does the same thing it did here. Okay, then, but what is it now? That's what the right-hand side does. It goes to the ith place in the array and adds 1 to that number in the array. Then what does it do? What does the left-hand side do?
It sets output array equal to the input array.
Yeah. Okay, so now combine the two together. What makes this different than that?
I'm actually not sure, because I would think that that would also add a number to the ith.
Yeah, this one goes to the ith location in the input array, right? And then adds 1 to that. And it stores it in there. This goes to the ith number in the input array, adds 1 to it, stores it in there. But they're not the same thing. There's a little bit different. And the difference has to do with what we did up here. Suppose the input array is 5, 4, 3. Okay, suppose that's what's in the input array. This goes to slot, one of the slots, gets the 5, adds 1 to it, which is a 6, okay, and then puts the 6 in the output array. Okay, notice, see, this line of code goes to slot I, say that's the first one, gets 5, adds 1 to it, gets 6, and puts 6 in the same place. Then it steps to the next one in the array, gets 4, adds 1 to it, puts that in the next array, in the output array. Then it goes to the next slot in the input array, which is 3. So that would be indexes. Yeah, if we think in terms of indexes, yeah, I'm using indexes. This would be the I variable now. The I variable is going to go 0, 1, 0, 1, oops, 0, 1, 2. See, I is going to go 0, 1, 2. Okay, so I will go 0, 1, 2. When I is 0, I get out 5. Okay, and then I add 1 to it and get 6 and put that in the output array. Then I will be 1. I'll go to the input array, get 4, add 1 to it, put 5 in the output array. Then the I will go to 2. I'll go to the slot 2, get 3, add 1 to it, and put 4 in the output array. Okay, all right. That's what this line of code does. That's what that line of code does. Now, what about this line of code? This line of code is a little bit different. You see, try to picture it. What does that line of code going to do? Okay. I is 0, goes to slot I, gets the 5. Adds 1 to it in place, makes this 6, and writes 6 down here into the output array. Okay. See, it incremented in that array. So now I is going to go to 1. You're at slot 1. You read the 4, add 1 to it, and write back the 5, and then the 5 gets copied down to here. Okay. Then you step to I equals 2. You read the 2 in the input array, that's this to slot 2, which gives you 3. Okay. But then that's written back into the array as 4. Well, then you increment 3 to 4 and write 4 back into this array. Okay. What you've done is you've incremented both the input and the output arrays, which is not what we wanted. We wanted to leave the input array alone and have an answer in the output array. What this did here was what the first one does. It makes the changes directly in the input array. See, this modified what's in the input array and just put the incremented numbers right back in the array where they came from. This line of code puts the incremented numbers right back in the array where they came from and puts the incremented numbers in the output array. So the input array gets changed and the output array holds the answer. They both hold the answer, which isn't what we want. It's duplicating the work. There's no need to change both the input and the output. So this is what we wanted. Okay, we wanted one that looks like this, where the input array stays the way it was and the output array holds the incremented numbers. Okay, so it's real important to see the difference between how these work. Okay, so it's real important to see the difference in how these two methods or these two ideas are working. You know, incrementing in place versus take a number out of the array, add 1 to it, but then put the result in the other array. Okay, so we don't want this one. So I'll comment that back out, but we don't want that one. That's not the way we want it to be. Okay, all right. So this is the one we want. This one essentially is copying from this input array to that output array. And we'll watch this in the Java visualizer and see how it works. Okay, so now after we've done all that incrementing, we have to return the output array. Okay, now see, this one returns an array. See, there's no return statement in this one. It doesn't return anything because the answer is in that array there. The array has just been changed. So that array got changed, we say in place. So there's no need to return an answer because the changes are right there. In this case, we created this new array, which is initially it's got all zeros in it. We stepped through the input array. For each number in the input array, we added 1 to it and put the result in the output array. So now the output array is holding the incremented numbers from the input array. And then we have to return the output array to whoever called the method. Okay. Now let's actually take these, at this point, I'm going to shorten this a little bit and let's put it into Java visualizer. Okay. So let's put this much in the Java visualizer. So we've got two of the increment arrays. So I'm going to copy this. I'm going to go to the Java visualizer. Now, okay. Okay. Now I need a main method if I want to test these. Remember we said over here that now over here, this one doesn't have a main method. So we put the main method over here. Now we can't have two files open in the Java visualizer. That's one of the limitations of the Java visualizer. It won't allow you to have two files open. So in the Java visualizer, we have to put the main method directly in our library. This is our library. Right now, the library's only got two methods in it. It's got this one and this one. It's only got the two in it. But we need to put a main method in here. We have to put a main method in here in order to be able to use the test in order to test these methods here, we need a main method. Again, you can't have somehow two files open in the Java visualizer, that's one of the Java visualizer is for working with small programs. So you have to have everything in essentially what amounts to one file. And that's, the Dr. Java doesn't have that restriction because it's meant to be, you can write real Java programs over here. And so you're much more likely to, in Dr. Java, to have two files. One file holds the methods and one file will test the methods. So this file holds the method and this one tests the methods. But here we have to combine them. Okay, so now let me just check that this compiles. We'll see, I made a mistake. Okay, oh, I didn't copy and paste. I somehow lost the P in public. Okay, so let me just check this, make sure this looks okay. Okay, so it compiled. Now it doesn't do anything. Yeah, so I have to go back now and let me create an array that I can use as input. So int array A equal, put some numbers in the array. Okay, so there's some numbers in the array. Okay, now let's call the first one. Let's call inc array in place. Inc array in place A. Okay, now let's watch what happens. Oh, what did I do wrong here? Oh, I forgot this is doubles. I forgot that this is actually an array of doubles. Okay, I don't care. I'm just go ahead and use integer numbers. Now they're all going to be converted to 5.0, 7.0, 2.0, 0.0, but that's okay with me. But okay. Right, so I started my main method. I'm going to create the array. Okay, there's my input array. 5.0, 7.0, 2.0, 0.0. Now I'm going to call inc array in place. Okay, notice how I still only have one array. This is a arrow to the array that was created down here. Okay, this is real important, that when I call this method, the method gets an arrow to this array. It doesn't get a copy of that array. Okay, so array A, that's main's name for it, points to this array. When you call inc array in place, it's got its own arrow to that same array. Okay, now it's going to step through it. Now watch what happens. It's going to change the array right in place. This is going to take, okay, I is 0. It's going to go to slot 0, find the 5, increment it to 6, and put the 6 right back where 5 is. See, 5 changed to 6. And it's going to go over here, and now it's going to, well, now it needs to go up here and increment I. So I is 1. Check that we're not at the end of the array. Now we're back down here. I is 1. We're over at this point in the array. We're going to grab the ith entry in input array, which is the 7, add 1 to it, and put it right back in the array. So now that number is going to change to 8. Okay. Then if I step through, 2.0 is going to change to 3.0. 0.0 is going to change to 1.0. 1.0 is going to change to 2.0. 8.0. Okay. Notice that I'm changing the array in place. Okay. Now I've got to the end of the array. Okay. And I'm done incrementing all the numbers in the array. And I'm going to return. At this point, when I come back here, A is a new array. Well, it's not a new array, but it's got new numbers in it. Now remember, I started with A being 5, 7, 2, 0. Now it's 6, 8, 3, 1. The array got changed in place. Okay. Now let's do this a little bit differently. I'm going to make a copy of that array, but I'm going to give it a different name. So I'm going to call it now B. So there's array B. It looks just like A, just a different name. So another version of this array. And now I'm going to call this other method inc array. Okay. So I'm going to call inc array, okay, of B. Now I'm going to do this wrong here. Inc array returns an array. It returns something, but I'm going to pretend it doesn't. I'm just going to do this. Okay. Okay. Now let's watch what happens. First, let me just real quickly go through this part here. This is the part that's going to create A, call inc array in place, step through A, incrementing everything, return. Okay. Now we create B. Okay. B's got 5, 7, 2, 0, 1, 1, 2. Okay. All right. Now enter inc array. Okay. First thing, okay, now inc array, it's got a pointer to the input array. Okay. Notice that this guy now is the array that inc array is working on. Now we're doing pretty sophisticated Java programming, and these pictures really help explain what's going on. We're doing inc array. It has this input array, and input array is really just another name for what we were calling B. In main, it's what we called B because we passed B as the parameter to inc array. Okay, so now we have to keep track of what's going on. This array is pointing to that one, not to that one. It's pointing to that one. Okay. Now we're going to create an output array. So now there's a third array. Inc array has its input array, which is the same array that main called B, and inc array has this output array, same length but full of zeros. Now it's going to take this number copied into there plus 1. Take that number, copied into there plus 1. Okay, so it's going to go through the array. It's going to go through the input array. Okay, now this line is going to go to the I slot of input array, get the number 5, add 1 to it, and write the number 6 down here. See, there's down there. Now it's going to go to this input, or it's going to increment I to 1. Okay, now we're at 1. So now we're going to look at that slot. That line is going to read, well, it's going to do 3 things. It's going to read slot 1. So it's going to read that slot and get 7. It's going to add 1 to 7 to get 8. And it's going to write 8 in slot 1 of the other array. Okay, so it's going to read that array, get a number out of it, add 1 to that number, then write the result over here. Remember, that's different than what this one did. This one would read a number out of the array, add 1 to it, and put it right back in the array. It put the number that after it added 1, it put it right back in the array. Now, when you add 1, you put the answer in the other array. So now add 1 to 7 and get 8, and 8's going to get written down there. Okay, just keep stepping through here. So now increment I to 2. I is 2. Do the same thing on slot 2. Read 2, add 1 to it to get 3, write 3 down there. Okay, so now step through, finish this. Okay, now I'm done. I'm ready to return. Okay, I'm going to return output array. The input array hasn't been changed. The output array holds the answers now. Remember, array A held the final incremented values. Array B hasn't changed. Here's where the final answers are. But now I find out I made a mistake. I'm going to return output array. So go finish the method. I didn't do anything to get the answer. I didn't store it anywhere. We've seen how if you return something and you don't store it, you lose it. See, that answer is disappeared on me because I didn't save it anywhere. Here, I didn't need to save the answer because there wasn't an answer. The answer was right inside A. A held the incremented values. Now, I told this method to increment B. What I should have done over here, let's go back to the code and fix it. This was kind of wrong. So here's how to fix it. I should say double array C. I need a name for the result is inc array of B. Okay. What I did wrong up here was I didn't do anything to capture the return value. See, I called the array and didn't do anything with the answer. Now I'm going to save the answer here. Okay, so what I'm going to do is I'm going to comment this out. So I don't want to do it over again. I'm going to comment that out. That's the wrong way. This is the right way. This is the right way to get the answer from inc array. Okay, so let's go visualize it. Step through it again real quickly. Okay, so I start off by creating A, call inc array in place. Inc array in place, it modifies A right in place. So I'm putting the answers, I'm reading the input and writing the output right into the same array. Okay, so now return. I don't need to capture a return value from here because A has been changed. Okay, now B is going to be just like A was. Okay, and now, instead of calling the wrong one now, I'm going to call the right one. I'm going to call inc array just like before. Okay, now the input array is this guy, 5720170. I create a place to hold the output. It's full of zeros right now. I step through the input array, copying the incremented values into the output array. Okay, so I'm stepping through the input array, creating the output numbers in the output array. Okay, I've reached the end. Okay. I'm going to return this array. Now, what that means is I'm really returning an arrow to it. And what's going to happen is this arrow to this array is going to get copied into C. Okay, so click, see, I'm going to return that arrow. See, that arrow to here, that's the arrow that I'm going to return to C. Now, unfortunately, the visualizer will show this array is disappearing in the next click, but then it reappears with its arrow in C. I think that's kind of sloppy on their part. It's a little bit misleading. It's really bad that that array disappears. So there's just before returning. So I'm at the last line of inc array. Okay, I'm at the last line of inc array. Okay, I'm about to return this arrow to my output array, what I called output array. So notice that output array and return value are the same array. This is my this arrow, this red arrow is a copy of that red arrow. So the Java system makes a copy of that arrow, and it's going to return that copy. It's going to return that copy to the variable C down here. But when you click forward, the array and its arrow disappears, and then one more click and there it is. Okay, so now this array got incremented to that array. But I have the input array and the output array. Whereas in the other method, when I called inc array in place, array A was the input and now it's the output. Very different. Sometimes this is what you want to do. Sometimes you want to take an array and make changes to it. Sometimes you don't want to make changes to the array. You want to take an input array and produce a return array that has the changes in it. Very different. There's many cases in programming where you have to make decisions like this. When you're doing something with an array, do you want to make the changes in the array you're given? Then you don't return anything. Or do you want to make the changes in a extra array and return the copied array? Yeah. Do you make the changes in a second array and return the second array? Or do you make the changes in the input array? Very important decision. And there's no right and wrong here. Sometimes it's done one way, sometimes it's done the other way. Sometimes people write their methods like this, in place methods that modify the input array, so it's the output array. And many times people write it this way, where they take the input data and return the output data in a separate array. They don't make any changes to the input data. Quite often, that's the better way. I mean, it's hard to say which one is better. Probably this is more common. You take an input array and you don't actually make any changes to it. There's the data in the output array. But if this array is billions of items long, you may not want to make a copy of it. And that's in the real world, that's something you have to worry about. If this array has billions of items, then to make a copy of it, you need 2 billions of items. Whereas if you change things in place, you just need the billions of items. So notice that this one didn't create more space in the computer. This one needs twice as much space because it needs to have the input array and the output array together. Okay, so usually if space is not a worry, you would prefer to do it this way. But if you're working with massively big arrays, then you might do it this way to save space. It also is a little bit it's a little bit faster because you don't have to make this new copy. If you go back over here, this step of even creating the input array, this step of creating this empty array, if this array had 1 billion items in it, it would still take a little while to make that array. So even creating an empty array with 1 billion items, you have to write all those zeros. Somebody has to write all those zeros in the array. They don't come for free. They have to be put there. So even if this was a massively big array, it would take twice as much space to have both the input and the output version. And it would also take a little bit of time to write all the zeros in the output version before you write the final values in the output region. Yeah. Now, if you're going to write final values in here, you might say, I don't need the zeros in here, but Java puts them in there anyway. You can't tell Java to make an array and not put zeros in it. So Java would create a billion item array, write a billion zeros into it, and then start copying these numbers into on top of the zeros. Okay, you don't have any choice about that. It would create the array full of zeros, so it would create the array, write zeros into it, then copy these numbers into it. So that's slower than the in place one, which does not need to make a copy of the array, and it just goes through the array one time and just puts the incremented numbers in it once. Okay, all right. So now we've seen two ways of working with arrays. I can take an input array and either make a change to it, or I can take an input array. I can take an input array and make a change to it, in which case I don't have an output array, or I could take an input array, make a copy, make another array, put the outputs in that array, then return that array. Okay? All right. Now, that's two of the four methods that were in this. See, there were four ways of incrementing array. Okay? So we've done two of them. Let's look at this third one now. Let's look at the third one. Let's add the third one to our library. So the third one, I'll just get the code from here and put it in the job visualizer. Whoops. Okay. Now, this one is actually kind of confusing. This one, this third one, the one with chaining, it's actually real popular for people to write methods like this, but they're confusing as heck. And a lot of people don't like them. Because let me show you it looks like this one. There's the input array, and I'm going to give you back an output array. But in fact, it acts like this one. It looks like this one, but acts like this one. And it can be extremely confusing. So this is a real challenge. This is where I want you to we're really using Java and programming. This is what real programming is about. Real programming is people write this kind of stuff all the time. It's a tricky thing. So this one, you think it's like going to be like that one, takes an input array and gives you back the output. But in fact, it doesn't really do that. Well, it's sort of a combination of these two things. It really acts more like this one. Remember, this one inked the array in place. Okay, so let's go here and read the code. Okay, here's the inc array chaining. That loop is exactly the same as the loop in inc array in place. See, that loop right there is exactly that loop right there. So it's actually doing the same thing as inc array in place. It's stepping through the input array, reading the numbers in the input array, adding one to them, and putting the answers right back in the input array. But then it returns a reference to the input array. Okay, and the question is, well, why would it do that? So it returns, notice see, the thing it returns is not a new array like this one. This one returned a new array that was filled in with the answers. This one returns a reference to the array you started with. So let's see let's play around with that one. So let's create an array. I'm gonna call this D now. So D is 57201. Okay. Now I'm gonna call inc array chain with D. Okay. So I'm going to call this inc array chain now. Okay, with D. Now it's got a return value. So since it's got a return value, I should, like I did before, I should capture the return value. So I'll call that E is, I'll capture the return value in E. So let's see what happens. Okay. So I'm going to call, here's my input array. It's the same input array I used for the other ones. You know, it's not the same array, but it's the same data in the array. So I put the same data in the input array, call inc array chain with D, and I'm supposed to capture an output because it returns an array. And I'm going to see what I can do with that output. So let's see what happens. Okay, so let me real quickly step through the first two. I've left them in there, so I'm going to real quickly step through. So there's inc array in place. Okay, so I'm done incrementing that array in place. Now I'm going to do the B array. Okay, B array has its output array. So I'm incrementing into the output array. So I'm putting the incremented values in the output array now. Okay, now I've filled the output array. Now I'm going to return it. Okay, so there's B incremented to be C. Okay, now here's the one we're interested in, inc array chain. What's going to go on here? There's D, starts out 57200170. Okay, now it acts just like inc array in place. See, it points to that array there, and it's just going to change it in place. See, notice that we're changing that input array just like we did the first case. We're changing it in place. Okay, so we got to the end. We've incremented the whole array. Now we're going to return a pointer. We're going to turn an arrow to the array itself. So now we're going to return this arrow to the array that was the input array. So we're just returning, it's kind of like a redundant, it seems like it's a redundant arrow. Okay, now we get back over here, and now we have two arrows to that array. And it is redundant. See, why would we want this? Why would we want two arrows to that same array? Okay, now here, watch what I can do. I can do something kind of interesting here. Every once in a while, people want to do the following. Here's how I'm really going to use that return value. I'm going to inc the array 2 times. I'm sorry. I want to inc the array 2 times. So what I'm going to do is, after I've inked it 1 time, I'm going to ink it a 2nd time. So what that's going to do is take this array D, pass it as input to this array. This array is going to give me back an answer that goes right back into this method again. So that lets me ink it 2 times. So I'm going to be adding 2 to this array D. Okay. Now up here, I could do the same thing by calling, that's the same thing as if I did this. But I can't write this line of code here. I can't put this guy inside of here. That doesn't make sense because this doesn't return anything. This does not give back an answer. So I can't make the answer from this the input to this. It's real tricky. I cannot make the answer from this the input to this because there is no answer. It doesn't return anything. So if I want to inc the array 2 times, I do it by calling the method 2 times in a row. On the other hand, now this increments the array and gives me back the answer, which is the incremented array, and I can make it call it again. Notice I'm calling this thing twice. Here I'm just calling it twice in a slightly different notation. This notation lets me, we call this chaining. This is inc array of D. Okay, so it's inc array of D, whereas this is inc array of A, inc array of A. They do the same thing, but you have this, you can write it this way a little bit differently. Some people like this way of doing it. They want inc array chain to return an arrow to the array they just modified, so you could call this method on it again, or any other method on it again. Okay, now let's watch what happens when we do this one. Okay, this one we'll call inc array in place 2 times. So let's watch, let's just step through it real quickly. I hope we don't hit the limit on what the visualizers. The visualizer, we're probably getting close to being what it's, you know, we're stepping through this array a lot of times. We're probably getting close to the visualizer's limit to what it'll be willing to do. Okay, so create the input array, call inc array in place once. Okay, so now we're going to increment 5 to 6, 7 to 8. So increment 5 to 6, 7 to 8, 2 to 3, 0 to 1, 1 to 2, 7 to 8, 2 to 3. Okay, we're done incrementing it. Return. Okay, now do it again. Increment 6 to 7, 8 to 9, 3 to 4, 1 to 2, 2 to 3, 8 to 9, 3 to 4. Okay, so we've incremented it 2 times. Okay, so now everything's been incremented twice. Remember, we started out with 5, 7, 2. Now we're at 7, 9, 4. Okay, so we incremented it 2 times. Okay, now let me skip over this one for now. Just keep the step through this one. We want to get to the chain one. Okay, now here's the chained one. Here's the array. Oh, here's the array D. Now I'm going to be doing this one here first. I'm going to start by going into here and calling inc array on D. D is that guy. Okay, so I'm going to increment, I'm going to be working on that one. Okay, see, I'm working on D. See how that's D? I'm working on D. Okay, so inc array. So 6 becomes 7, 7 becomes 8. Wait a minute. Yeah, 5 became 6, 7 became 8. Okay. Okay. Now here's the tricky part. I've inc arrayed this guy once. Okay. Now what? And then I got returned an arrow to him, and then I'm going to call this one again with the return arrow to this one again. Okay. See, I'm back in inc array. Now I am doing this one, pointing to the same array. Now I'm going to increment 6 to 7, 8 to 9. I'm still working on the same array. Okay. Okay. Now I'm done. Okay. Now I'm finished, and I've incremented this array 2 times. I incremented it once by, I incremented it once by calling inc array. The answer to this was an arrow to D. So that arrow to D got passed to this guy once again. But it's what we call chaining, because it's inc array of D, as opposed to what I wrote over here, which is inc array in place of A, inc array in place of A again. See, there's no chains. This is a chain here. If I wanted to increment the array 3 times, up here I would write that 3 times. Oh, I can't edit here. That's how I would increment the array 3 times that way. Here, I would increment the array 3 times by chaining it 3 times. Inc array gives you back an answer, which you increment again right away, which gives you back an answer, which you increment again right away. So that's called chaining. It's like a chain of, instead of being like this, inc array A, inc array A, inc in place A, inc in place A, inc in place A, where I keep changing A. Here I'm saying, well, start with D, increment it, increment it, increment it. So increment D 3 times. Okay, it's just a different style of writing. Some people like this style, but it's confusing because if we go back up here, okay, if we go back over here, this and this don't look alike. This one doesn't return anything. This one returns an array. In fact, this one looks like that one because it looks like it takes an input array and gives me back an output array. This one takes an input array and gives me back an output array. And what's real subtle here is in this one, the output arrow is to the input array. The arrow that this one's giving me out is an arrow to whatever was the input array. Okay, that's weird, but a lot of people write their code this way. Here, the arrow I got out was a new array that was created by this. It was a copy of that input array. A copy, and then you incremented everything in the copy. Okay, so you look at these, and you have to be very careful that they're very different. Okay, this one acts more like that one and doesn't really act at all like this one. It modifies its input array. This one modifies the input array and and then gives you an arrow to the modified array. Hey, that's weird, okay, but not uncommon. Now let's look at the fourth one. Okay, now there's a fourth one. We're still going to do the same thing. We want to take an array and increment all the numbers in the array. So here's going to be a fourth way to do it. So I'm going to just copy and paste it into the visualizer. Okay. This is going to take 2 input arrays. And what it's going to do is the answer is going to be in this array. It's going to read this array, write this array. Okay, read this one, write to this one. It won't read this one. It doesn't care what's in it. It's going to write over it. So it's going to read this one, and it's not going to modify it. It's not going to make any changes to it. And it's going to write the answers there. In a way, it's a combination of everything above. Notice how this method modified that array. This one modified that array. This one only read that array and put the answers into the output copy. In a sense, this one kind of combines everything. It reads that input array, but instead of making a copy of it, it says, you give me the thing that's going to hold the output. So before you call this array, you have to provide the input data and space for the output data. Okay. Now, this thing returns an int, and we'll see in a second why does it need to return something? If the output array is like this one, where the output's just stored right in the array that was the input, see, this one didn't need to return anything. Okay. Now, this one returned a pointer so you could chain, but this one didn't need to return anything. So down here, what is now, and notice it's only returning an int. Okay. What it's going to do, it's going to return 0 if there was no mistake, and it's going to return -1 if there was a problem. The problem might be the input array and the output array aren't the same length. Like if the input array is length 5 and the output array is length 10, you can't really copy the data from here into here. Worse, if this one has length 10 and this one has length 5, there's no room to copy the data from this one into this one. So the first thing this method does is it checks that, well, at first it checks that there really is an input array. It checks that there really is an output array, because you can call these methods with null, meaning no array. So it checks that there really are arrays. Then it checks that they have the same length. Okay. If all those conditions are met, there really is an input array, there really is an output array, and their input and output arrays have the same length, then it increments the input array and puts the result in the output array. Okay. Then it copies. Now that's acting like inc array. See, it acts more like inc array. it copies from the input array to the output array, except that it didn't make the output array was given to it. But it copies from the input to the output using the output array that was given to it. On the other hand, if these conditions aren't met, if one of the arrays is missing, it's null, or if the arrays don't have the same length, it returns -1. Okay, so that gives you a way of telling if this thing succeeded or not. Okay, just real quick, let's just call it. Let's do what I have to do now. Here's how I would call it. Call this E. Okay, there's my input array. Let's see, this was called, oh yeah, just inc array. Oh, well, first, there's my input array, and I need an output array. So I'm going to say double array F, and I'll make it a new, new int array of size. Well, I'll make it the same size as E. So E dot length. Okay. So here I'm creating an array that's full of zeros, the same size as that one. Okay. Then I'm going to call this method with E is the input and F is the output. Okay. Oh, let's see. I forgot that these things are doubles. Okay. Oh yeah, see, I finally hit the limit. Okay, so I have to like comment out some of these other ones. So let me just comment out all the other ones above there. Okay, so we just do this one. Okay. There's E, there's F. E's the input, F's going to be the output. Now I call inc array. Inc array says this one's the input, this one's the output. It's going to copy from here to here, here to here. So see, it's putting the incremented values in the output array. Okay, so it's pretty straightforward. And then when it's done, I'm back here. There was the input, there's the output. Okay, so that works fine. You just create the output array yourself before calling inc array, as opposed to the second method, as opposed to the second one, which would require you, which produce the out. I'm sorry. This one created the output array for you. See, it created the output array for you. This one, you create the output array before calling it. So just slightly different versions. Okay. So if we go back over here to the library, this one creates the output array for you. This one, you need to create the output array for it. Okay. This one creates the output array for you. This one, you create the output array for it. Otherwise, they act the same. Okay, so those are pretty subtle differences. Yeah, in the world of Java programming, you see all four of these all over the place. Sometimes they'll write a method in this style, sometimes in this style, sometimes in this style, sometimes in this style. You've got an input array and an output array. Here, the output data is written on top of the input data. Here, the method creates the array to hold the output data. Here, the input data is written on top of the output data, but you return a pointer to the input and output data so that you can keep calling the method over and over again. You can chain the method. And then here, you create the input array and you create the array to hold the output, and then you call the method with both the input and the output. Okay, so four ways of more or less doing the same thing. And it's tricky. Yeah, it's a lot of thinking. If you go through and visualize these, I'll put this example I'll put a link to it. You really have to think hard about how these things are working different. How this one, this one, this one, and this one. Your job is to really convince yourself that you can remember how these 4 different ways of doing the same thing do them differently. Okay, that's your job, is to think, to remember in your own mind why there's 4 ways of manipulating an array. You give me an array and you want an answer from the array. And there's 4 ways to do it. Change the array I give you, make a copy of the array I give you. There's 4 ways you can make those, could give me an answer for an array. Okay, so we'll quit there. We've run out of time. Okay. Next week, we'll start another topic. Okay, so next week, we're going to start talking about classes. And we'll see that some of this stuff will come back to us. We'll eventually talk about methods and arrays again. And so we'll come back to these ideas a little bit. But here, what we've done is a real sophisticated use of arrays in methods. Really interesting, different ways of thinking about how you could program. Okay, so we'll quit there. Have a nice weekend. Oh, anybody have any last second question? Any kind of question you have about these examples? Okay, if you have questions at all, send me email. Okay, so have a nice weekend. Bye-bye.